Hello, everybody, and welcome back to Creation Myths. So I have kind of an off my regular schedule video for today. I'm going to get into it in just a second. Just making sure the sound sounds okay here. All right, it looks good on YouTube. Friends in the chat, please let me know if the sound or the video has any problems over the course of the stream. Everything seems okay on my end, but you never know. So just let me know. I have the chat open. If there are any issues, I will see it. So, hi everybody. Welcome to this somewhat off-schedule Saturday night stream for me. What we're going to do here is talk about a recent video from my friend Donnie at Standing for Truth, in which he specifically set out to address some arguments that I have made recently and have been making for a while now, a few years. And so I'm going to pull up this video in just a minute. It was a long video. It was about an hour and a half long. And about the second half of it is relevant to what we are going to talk about. The first half was addressing Dr. Stefan Frello. And then the second half was about my stuff. I'm going to clip this video and we're just going to look at that second half. So let's get going with this here. Like I said, if anyone notices any audio-visual issues, let me know. But everything looks good on my end. So I am going to pull this up and let's get right into it here. Actually, before I pull up the video, let me just kind of set the stage and we'll talk about what we're going to talk about here. So the argument that Standing for Truth is responding to here is the argument that I made in my debate back in January with Dr. Jerry Bergman regarding common ancestry versus common design. It's the argument that's based on a nested hierarchical pattern of similarity within unconstrained DNA sequences that exist no matter how far back you go in terms of phylogenetic similarity. You can see this within very narrow groups. You can see it within very broad groups, the same pattern that exists. And the point here is that we are building this nested hierarchical pattern using sequences that do not experience purifying selection. So it's sequences where mutations can accumulate freely. And we can demonstrate that that's the case experimentally. You can just show, or through direct observation, you can show based on the rate of mutation accumulation that a specific region in a genome is not experiencing purifying selection. The kind of other important aspect to this argument is that mutations are probabilistic, which is to say they're random. We can't say in advance which specific mutations are going to occur. And this has been demonstrated directly experimentally. I actually covered this relatively recently, and I've linked that video down below addressing the claim from creationists that mutations are not random. I've dealt with that. That video is linked down below. So we're not going to entertain the notion that mutations are something other than probabilistic. They are. We have direct experimental evidence of that. That's the end of that discussion. So what this means is that if you have separate ancestry, right, you have this kind and this kind and this kind and this kind all created separately, then you're going to have variation accumulating independently within each of those kinds. And because mutations are probabilistic, those variants that accumulate within each kind are going to be uncorrelated with each other. So once you get above the level of kind, you no longer have nested hierarchies. You wouldn't see them because the variation is uncorrelated. Common ancestry, on the other hand, predicts nested hierarchies no matter how far back you go, right? You're going to see lower and lower levels of similarity as you get more and more distant in your evolutionary relationships, and it will form a predictable pattern, a nested hierarchy. And that's exactly what we see. When we actually look at the data, we do see those nested hierarchies. And that's it. That's the whole argument. It's not more complicated than that. That's it. So that's what Standing for Truth, Donnie, is setting out to address in the video that we're going to talk about tonight. Now, before we get to the video, I do want to give Donnie some credit because, you know, I've been making this argument for a couple of years. Other people have been making this argument for, longer. I think to the extent I've brought any innovation to the table, it's in emphasizing the utility of unconstrained sequences in it. But I'm not the first person nor the only person to make that argument. I just very specifically make it a centerpiece of my argument. But me and other people have been making this argument for a long time. And creationists tend to not want to touch it. They just don't want to go near it, which I think is understandable because, I've been saying that this observation, this nested hierarchical pattern, is the single best piece of evidence for universal common ancestry of all cellular life. Like, that's it. So I understand why creationists don't want to tackle this head on. It's hard to address. So I do want to first, props to Donnie for, giving it a try, right? Someone's going to do it. Great. I love it when creationists attempt to address the arguments that I and other people are making. So I want to start there. Good job, Donnie, for trying. So as we go through this video, I want everybody to be thinking, everyone watching this, be thinking, what is the counter argument here, right? Because in order to address the argument that I'm making, the argument that Donnie is specifically addressing, you have to have a specific, no, this is the actual explanation for the observations we're talking about. What's the alternative explanation? And I've watched this video a bunch of times, and I'm not actually sure what the alternative explanation can be. At the end tonight, we're going to summarize 4 arguments that I think Donnie makes in here, and none of them work. But we're gonna once we get to the far side of this, we're gonna summarize what I think the arguments are. And as you all know, and as I hope Donnie knows, I really do try hard to accurately represent the arguments that I'm responding to. I'm not out here to strawman anybody. I'm actually, we're gonna go through this and we're gonna see if what Donnie says matches my representation, and I think it will. But the arguments that Donnie makes, the points he makes, I think are not directly addressing my argument, as we'll see. And if anybody can find some nugget of an argument in there that more directly addresses the point, please point it out to me, because I've tried, and we're going to go through it, and I don't think it's there. So with all that stuff out of the way, let's go through this video. I will
Dr.
also
Dan
add, starts playing right away. I will add that I am going to show clips that are going to be 1 to 2 minutes long on average, and then we're going to talk about it. There are going to be sections that I skip because it's either repetitive or irrelevant, and I'm just not going to worry about it. So I'm going to point out when I jump, and I invite everyone to go back and check my work and make sure in those areas that I skip that it is actually irrelevant or repetitive. Again, not trying to straw man anybody here, putting all my cards on the table up front. So with all that out of the way, let's get into this. I'm going to let this play for about 2 minutes, and then we'll talk about it. Oh, please in the chat, as it's playing, please in the chat, just let me know if the volume is okay, if everything sounds okay. Thank you.
And so next on our agenda is Dr. Dan Stern-Cardy now. Now, I do appreciate our good friend Creation Myth's ability to put forth an intriguing challenge that allows us in the world of biblical creation research to put in the time, the energy, the work, the effort to engage in a sophisticated manner the challenge or challenges. And what this kind of back and forth serves to do is helps us who hold to the biblical model of ancestry. It helps us to really refine our model and refine our arguments. And so for that, I do appreciate Dr. Dan Stern-Cardy now in his attempt to falsify the separate ancestry model. And so let's have a look here at what we're dealing with. Here is a summary of Dr. Dan's challenge that he has issued on numerous occasions. He's issued it in our open mic debate series going back over a year ago, possibly even a year and a half ago that we did. It was about every couple of weeks we did an evolution open mic challenge, bring your best evolution, change our minds, refute us wrong. And for 2023 and much of 2024, we engaged in many nights of debate. And so he presented this challenge then. He refined it a little bit from my understanding, and he also presented it in his debate with Dr. Jerry Bergman, a very thought-provoking, a technical exchange that I very much enjoyed. And I appreciate Dr. Dan and Dr. Bergman's time for that debate. And so here is a brief summary of his argument. And so Dan says this essentially: if separate ancestry is true, there should be a lack of nested hierarchies or a lack of a nested hierarchical pattern in unconstrained sequences. These sequences should evolve neutrally as they accumulate mutations over time. Therefore, there should be no or very little hierarchical signature between kinds. Okay, he'll argue that there can be hierarchies within kinds, but not between. And he says this is because mutations would accumulate randomly and scramble any hierarchy. Okay.
Okay. I just want to start by saying, yes, that is a fair representation of my argument. Let's start there. He's not straw manning me. I think that was a fair representation of my case. Cool. All right. So let's go for, I apologize for the ratio of video to commentary early on. We're going to change that balance as we go. But for now, it's going to be a fairly high ratio of original video to my commentary as we get through this intro stuff. So we're going to go for about another 2 minutes, but I just wanted to point out first that, yeah, that sounds fine. That was a pretty good representation of my argument. Cool. Let us continue.
And so let's go over a few things, a few definitions, a few important points related to Dan's argument here. And so when you hear the word constrained, what that means is it's limited in its ability. So you have a sequence in the genome, region of the genome that is limited in its ability to change or alter since it's subject to natural selection. As compared to unconstrained, okay, this is where his argument is mostly focused on, unconstrained sequences of the genomes of biological organisms, unconstrained being regions of the genome that are not subject to selection. So if they're not subject to selection, they will change over time as mutations accumulate. Okay. If you really get down to it, Dr. Dan, okay, he does believe that the majority of the genome is still junk and non-functional. Okay. So he would say that most of those unconstrained sequences would be junk. Okay. Obviously, they're not important enough, according to his model, for selection to preserve over time. Okay. Remember, when they look at differences between organisms, they see those differences as a reflection of time. Now, I will say, just in case Dan's listening or he responds to this, Dan would say, for the sake of this argument and challenge, it doesn't matter if it's functional or not. That's what he would say. Okay. Mm-hmm. But I'm just saying, bigger picture wise, the evolutionary community, those that hold to the junk DNA paradigm, if they're only going to say that 10 or 15% of the genome's functional, well, that means most of it, according to their viewpoint, would be non-functional.
Okay, let's just pause there and let's make sense of a few things here. So first, when he talks about selection, I just want to make clear for everybody that we are specifically talking about purifying selection. I'm, in my argument, talking about sequences that are not experiencing purifying selection. Purifying selection is natural selection against changes to the sequence. It's selection against new variations. So if you have a sequence that's doing a job, it's well adapted to do that job, and that job is very important, if you change that sequence and you get worse at the job, whatever it is, you have selection against it, right? So the individuals with the mutations will have lower fitness than the individuals without those mutations. So over time, that sequence will tend to stay the same as a result of purifying selection. That's the type of selection that we're specifically talking about here. Second thing I want to point out with this little segment, and it's a really important thing, and it's something I'm going to say over and over and over again as we work our way through this, is that functionality does not matter. He's correct to say that I will say that functionality doesn't matter. It doesn't matter. It doesn't matter if the sequence is functional or not. It doesn't matter if it's junk DNA, highly important, whatever. It totally does not matter. What matters is that sequence experiencing purifying selection? And the answer is that we can directly observe whether or not a sequence is experiencing purifying selection. We can assess that by looking at the rate of mutation accumulation. So we can look at specific regions of the genome and see how they have very low rates of mutation accumulation. They tend to stay the same. That region is experiencing purifying selection. The regions that are experiencing higher rates of mutation accumulation are experiencing weaker or no purifying selection. So we can, this is not a question of is it or isn't it functional? Doesn't matter. If it's unconstrained, we can directly observe that. We can make that determination just looking at the substitution rate in the sequences that we're dealing with, right? So keep that in mind, everybody. Function does not matter for the argument I am making. I also just want to highlight, before we move on, highlight a super chat from My Unfinished Journey. Hail Nero, Dr. Dan, and an attempt at a response. This is for $2.22. Thank you, My Unfinished Journey. I appreciate your generosity. So let's continue. We're going to go for about a minute and a half here. So let's just continue on. This section will be, I won't have too much to say about this, and then we'll get into some good stuff here.
Okay, so they see DNA differences as being a reflection of time, right? So they would look at the DNA differences between humans and chimpanzees as being a reflection of time since their last common ancestor and when that common ancestor diverged into two lineages. That would have been less time, okay, a shorter amount of time has passed between those two organisms than, let's say, you bring in a mouse, compare humans with mice, compare their genomes, you'll see more DNA differences, which they would argue, according to the model of common descent, reflect more time since divergence. So therefore, humans and chimps share a more recent common ancestor than humans and dogs, or humans and fish, or humans and mice. Okay, mice, though, being within the mammal group, right? Kingdom, phylum, class, order, family, genus, species. And so DNA differences being a reflection of time, and therefore the nested hierarchical patterns that exist in the biological world being a reflection of descent with modification rather than design. Okay.
Okay. Just want to pause there to say, again, that was pretty good. He's not strawmanning the evolution position here. That was, I think, a reasonable explanation, which, you know what, we all know, for those of you, my regular audience, people watching, if you're familiar with creationist arguments, you know that we get a lot of strawmanning, we get a lot of misrepresentation of the evolution position. So I just want to point out when creationists don't do that. And overall, that was pretty good. So far, so good. So let's pick this up. We're going to do about another minute and a half. And we're going to have some stuff to talk about, but we are going to do some time jumping soon because we are going to start getting into some somewhat tortured analogies and irrelevant material. So let's do about a minute and a half. We'll talk about it. We'll go from there.
And so it is interesting that Dan would basically say that the function aspect of this debate doesn't really matter, but I do want to point out that just because a region is not conserved does not mean that it's not functional. All right. There are sequences in the genome that we understand are not as important as, let's say, other sequences that are involved in heart function or cellular respiration, right? Like the mitochondrial DNA could be subject to more selection because of its importance. Whereas a lot of your autosomal nuclear DNA, you have regions that are there to tolerate error, more error than other positions in the genome where you get hit with a mutation in a gene that's important for the heart or the brain or respiration. Then guess what? That organism is going to die, and there's not going to be reproduction, because that's what selection is: differential reproduction. Who's reproducing the most? Who's having the most babies? Okay. Another factor, another point to consider is that mutations in these sequences, the unconstrained sequences, may have functional consequences that we're simply not yet aware of, because we are only in the infancy of understanding the DNA language. There's still so much we don't know about DNA function. It would be like, and I'll use a couple of now.
Okay, we're going to pause it there because we don't need to hear the analogies. We do not need to hear the analogies. So this section, I want to point out again that it's not about function. And he said, Dr. Dan would say it's not about function, and then he just goes on and talks about like function for a minute and a half. And folks, whether the sequences in question that make these nested hierarchies are functional or not doesn't matter. As I said, we can directly determine whether they are constrained or not, whether they are experiencing purifying selection. That's what matters. As he said, there might be function in there that we don't know about. Sure, you could have unconstrained sequences where, for example, the length of the sequence matters, but the actual nucleotide sequence doesn't, right? That's a thing. Sure, absolutely. But there can't be, in the sequences we're talking about, functional consequences to mutations that we just might not know about. We know that that's the case because they're unconstrained, and we can empirically determine that they are unconstrained. That's the big point here. We can empirically determine that the sequences are unconstrained. So whether we know what the consequences of the mutations are or not doesn't matter. We can directly determine that there's a fitness cost or not by evaluating whether or not they're experiencing purifying selection, right? If there are mutations where we don't know the function, but it turns out it's important for some job, we haven't figured out what that job is, but the sequence matters for doing some function that we haven't yet figured out. If there are mutations that disrupt that function, that's going to be subject to purifying selection, right? If there is a cost to it, it will be subject to purifying selection, and we can empirically detect that, right? We can directly show that that's the case. The sequences that I'm talking about, that I'm basing my argument on, are not that, because we've determined that they're unconstrained. They are the sequences that are not subject to purifying selection. Constraint matters. Function does not matter. Donnie, please stop talking about function. It just doesn't matter. Okay, folks, I think you probably see a trend here. It just doesn't matter. Now, he goes into there's an analogy here. We're just going to skip it. It's like 4 minutes and change. So we're just going to jump ahead to the next part here. And we're going to go for a little under 2 minutes here. We got to jump ahead to 12 and about 12 and a half minutes. So we're going to jump ahead here. And then we'll pick it up. We can pick it up right about there. Okay, so we're going to go ahead here and listen to about 2 minutes here. And then we'll talk about Donnie's continued attempt to address the argument.
That's looking at the bigger picture. Another thing is, how does Dan know that these differences that he even calls unconstrained are the result of mutations? Because remember, it is the evolutionary community, it's the evolutionary model that explains all DNA differences as being the result of mutations over time. The creationist model explains the majority of autosomal nuclear DNA differences as being the result of created heterozygosity. or design diversity. And so differences that you see in unconstrained sequences across kinds could be a reflection of the different functional requirements or the unique functions associated with those creatures. And perhaps those are the ones that would be more dissimilar and creature specific. Okay. Because obviously you have some creatures that look a lot different. And so they're going to have different functions, different features that need to be used and utilized as compared to your conserved regions, which could have more similarities across biological creatures because those are the parts that are more similar anyways, like an engine, right? That's going to be pretty specific. That's going to be pretty generalized to all modes of transportation. And so perhaps these kinds, they have specific differences that reflect the uniqueness of the respective creatures. Okay, that's certainly a point worth considering. We can also make testable predictions on that. That's for another video, getting into detail on that. And so one of Dan's main...
All right, hold it right there. I just want to go back just to set my time point correctly. Okay. So I want to talk about this segment a bit. First, he alludes to the concept of created heterozygosity. He didn't say those words, but that's the argument he's making when he's talking about built-in differences, explaining the variation within created kinds. He's talking about created heterozygosity. Now, I've actually done the math on that. I've actually said, okay, let's assume we have the maximum number of alleles in our ARC pair, and we have recombination. Is it possible to generate the diversity that we see in modern humans, for example? I've actually done the math on this, and I've shown that it can't work. The rate of recombination that we directly observe is just way too slow. Now, no creationists have done the math on their side to show that it can work, nor have they directly taken my math and tried to refute it specifically, right? So I've linked my video on created heterozygosity down below. I've already added all the links to the description. I know sometimes I'm bad about links in the description. I already did it for this one. It's down there. So if you want the math on created heterozygosity and why it doesn't work, you can check out that link down below. Now, regarding the other thing that he just talked about, the differences across kinds. And can they be functionally significant? Blah, 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 right? We know that what we're talking about can't be functionally significant because they're unconstrained, right? There's no selection operating on the sequences that I'm talking about when I'm making this argument. And remember, he's responding specifically to the argument that I made in my debate in January with Dr. Bergman. We're talking about unconstrained sequences. That's how we know they don't matter, because they can change without having an effect on the organism. And again, we can directly observe that that's the case, right? We can document by looking at the substitution rates that they can change without having a cost to them. So those differences can't be responsible for the differences between the kinds because they don't have an effect, right? That's the point. They can change without mattering. That means they're not responsible for the differences, like phenotypically, that we observe. Now, as for that last little bit, I love just the last little bit there, last like maybe 10 or 15 seconds, talked about how, oh, we can make testable predictions, and I'll get into that in another video. Donnie, I'm going to speak to Donnie for a second. Donnie, you should have done that in this video. You should have gone into the testable predictions and which ones are correct and which ones are not in this video, because my whole thing, my whole argument that I'm making here is about competing predictions. Right? We have two models that make opposite predictions, and we can evaluate those predictions. And it turns out when you do that, my predictions are right and yours are wrong. So if you want to refute that, you need to like show your work, right? You can't just say, oh, and we can go into this, eventually. No. If you're like, I'm going to address this now, and at the end of this video, he says, I have done a complete job. This is the answer. Right? You can't do that and also just leave out the showing your work part of it. So Donnie, I think you need to go into those predictions if you say you're going to address someone's argument specifically and not just say, we'll get to them at some point. Cover the predictions, do the math, Show your work. Thank you. All right, let's see. Are we at the right time? We're going to jump ahead a little bit here, just like 30, 40 seconds, because like 45 seconds, we're going to jump because Donnie goes is a little bit of a digression here about his kind of general policy of responding to arguments that are made in debates that he either hosts or moderates. And his general policy is to not, but for this one he is, because I've made the argument elsewhere outside of the debate. That's cool. All good. Perfectly reasonable policy. Okay, so we're going to jump to right about here. I will jump to there. And now we're going to get into kind of a different kind of branch of the argument that Donnie is making here. Okay, so let's play this for about 2 minutes, and then we'll talk about it.
Is best. Okay, so let's focus now on his challenge in regards to unconstrained sequences. So as we covered earlier, he will argue that if young earth creation is true, if separate ancestry is true, then there should be no nested hierarchies in unconstrained sequences. He says these sequences should evolve neutrally as they accumulate mutations, and so there should be no hierarchical signature between kinds, and supposedly this is an irrefutable challenge. Okay, firstly, before I go through some of these points here on the slide, even if what Dan is saying is true, we've only been accumulating mutations in neutral regions of genomes for what? 4,500 years since the flood. And the genome is big, okay? Your autosomal nuclear DNA, you got 6 billion letters. You get 3 billion from mom, 3 billion from dad. Okay, we're diploid. And so in 4,500 years, you're not going to accumulate enough DNA differences or enough mutations to scramble any hierarchies that are there. There just simply hasn't been enough time. Okay, God could have created hierarchically. That's what it looks like he did, which makes sense because the Bible says that we're created in the image of God, which means there must be something about us that reflects the divine. And it just so turns out that human engineers design and build things in what? Hierarchical patterns, homologous patterns. They even design interesting transitional like vehicles. Okay, interesting mosaics. And so if God created hierarchically, which the evidence seems to suggest that he did, and it's only been 4,500 years since the flood, mutations accumulating neutrally in a neutral fashion are not going to significantly alter any of these created hierarchical signatures or patterns, okay? But I will say,
let's hold it right there. Let's talk about that segment because I think as a few of you may have noticed, a few of you hanging out in the chat may have noticed that there was just a little bit of a leap of logic there that may not be grounded in observation. So the argument in this little bit that Donnie is making is that if we have separate ancestry and then everything gets off the ark about 4,500 years ago, and they were created with a hierarchical pattern of similarity, then in those 4,500 years, you're not going to scramble the created pattern sufficiently to obscure it, as I'm saying, right? So he's basically disputing what I'm saying the creationist prediction would be for separate ancestry, okay? Now, first, I'll actually point out here first that in my debate with Dr. Bergman agreed with my interpretation of that you would obscure the pattern over that time period. But Donnie and Dr. Bergman are two separate people. Donnie's making a separate argument. But what he is saying is not universal to all creationists here, right? Now, the bigger problem here is what he said kind of towards the end there. And I'm just going to read this quote I took down. Quote, if God created hierarchically, which the evidence seems to suggest that he did, what evidence? What evidence is there that God created unconstrained sequences hierarchically? That sounds like it's an assertion, not a claim based on any specific observation. Because again, we're talking about specifically unconstrained sequences, sequences where you can change them and there's no functional consequences to changing that DNA sequence. Why? This is a question for Donnie and for any other creationist who wants to go down this road. Why would the null hypothesis be a nested hierarchy at creation for the unconstrained sequences? You need a specific answer to that question for the unconstrained sequences. Creationists will try to say, oh, well, the functional ones, they're going to make a nested hierarchy, right? So this gene and that gene across different species, right? The same gene across different species, they're similar and they make a nested hierarchy according to how similar the species are, right? That doesn't actually work either, and we can do the math on that, but that's not the argument I'm making right now. What I'm making right now has to do with the unconstrained sequences, the sequences where the sequence does not have a functional consequence. So why is the null hypothesis for that a nested hierarchy? You need to actually justify that assertion. You can't just make it as though it's obvious to everybody, right? Now to the bigger point. Only 4,500 years, that's not going to result in enough mutation accumulation to scramble the created pattern. Okay, show your math on that. That is a quantitative claim. Show your math. Because I've shown quantitatively that created heterozygosity can't generate the diversity you need. So you need mutations to generate that diversity within each created kind. Created heterozygosity can't do it. I've directly done those calculations and shown the math. And again, that video is down below. If it's mutations that are responsible for the diversity, you're going to break up the kind of preloaded nested hierarchical pattern. I also, in my debate with Dr. Bergman, I referenced a couple of papers that specifically dug into this. In my opening, I showed the papers. I showed the titles of the papers and quoted them. And those authors quantitatively described, they quantitatively tested the concepts that I described qualitatively during that debate. I didn't go into the actual calculations in the debate, but other biologists have, and I cited a couple of those papers. So on the creationist side, who's done the math to show that those calculations are wrong? Has Donnie done that math? Dr. Rob Carter, Dr. Nathaniel Jeanson, Dr. Georgia Purdom, any of them? Have any creationists actually done the math in support of the claim that Donnie just made? Show your work. Provide a link. Show me the reference. If you haven't done the math, you have no basis for making that claim, especially when people have done the math the other way, showing that it's not the case. Now, I've linked those papers from the debate, the papers that I referenced in my opening during that debate. I've linked those papers down below, so anybody who wants them, there you go. You have the links to those papers. And for any creationists who want to take a stab at showing that that math is wrong, there they are. There's the papers. It's all laid out there in black and white. Go for it. Power to you. I hope they try. All right, we are going to continue here. This next segment is only going to be about, it's a little over a minute, and then we'll jump a little bit, and then we're going to skip around a little bit from here on. So let's go for about a minute, and then we'll pause again.
If God created hierarchically, what that means is baraminology in general, which is the study of created kinds. It is going to be difficult because if God created the designed order hierarchically and designed diversity is true, right? God front loads the original created kinds with pre-existing DNA differences. That means if scientists come an hour after the creation event and they start examining all kinds of creatures, all kinds of the original created kinds, and they perform genetic sequencing and then they do comparative genomics on these creatures, since God created hierarchically and with pre-existing DNA differences. But if these scientists didn't know, they came about an hour after, you know what they're going to conclude? Descent with modification, because what are they going to find right after creation? Hierarchical patterns, pre-existing DNA differences that just came about, pre-existing from what? From God's hand. Okay.
let's pause there because the framing for that is a little bit bananas. Okay. Now, first, yes, baraminology is hard, right? This is the kind of study within creationism, young earth creationism specifically, of what are the boundaries, the lines between the created kinds, right? And I want to point out this, this comment right here, because this is exactly right. This is the genetics version of apparent age, and God created the fossils that way. Yes, fade to gray, post-diluvian, flying glaciers. Yes, that is exactly right there. Absolutely. So it's like baraminology is hard, and to date, all the creationists who have tried to come up with an objective standard for delineating between the kinds have failed. Answers in Genesis very famously has their list at the Ark Park. That, you know, they have all the kinds listed out, but it's super arbitrary. There's no like objective standard there. Other organizations, and I'm thinking more along what Dr. Joel Duff calls like the new creationists, they're like objectively trying to come up with, you know, ways of delineating between the kinds, and it's hard. You can't do it because kinds are fake is the problem. But like, yeah, some, you know, creationist organizations are trying, and it's a difficult problem, right? This baraminology problem. So yes, but also bigger problem for what Donnie just said is that we're not looking an hour after, you know, we got off the ark, right? We're talking about, you've got creation, and then you've got the ark bottleneck. And now he's saying, okay, you know, an hour after creation or an hour after the ark, if you looked at it, it would look like common descent, but they're actually separately, you know, independently created kinds. No one's looking an hour afterwards. I think if we were to say the ark, you know, we're evaluating this from an hour after everything got off the ark, one, the kinds would be much narrower, right? So there would just be less variation, so it'd be easier to tell them apart. But also, yeah, what he's saying, you know, would have merit, right? Because there haven't been that many differences that have accumulated in that hour since they got off the ark. But we're not looking an hour after the supposed ark. We're looking 4,500 years, right? So you have to account for that. And again, you know, the math on this has been done. I and other people have done this math. If the young earth creationists, for example, want to propose vastly different historical rates of mutation and mutation accumulation from what we currently observe, then you can make the math work in the 4,500 years. But I don't think anyone's proposing that. I don't think any creationists are saying the mutation rate was, you know, exponentially higher in the past. I don't think anyone's saying that. So I don't know. I don't know what to say. I don't think talking about this in the context of what things would have looked like an hour after they got off the ark is relevant to the modern conversation. So we're going to skip a bit here because it's repetitive. He goes back to the point about how God could have created hierarchically. We already talked about that. We don't need to do it again. So we're going to skip here to almost 20 minutes in. Let's go up to, let's go to about 1950. That'll be fine. And we're going to go for about 2 minutes here before we do another short time jump. And then I'll tell everybody, we are currently sitting at about 20 minutes in here with 1950. And we're actually only going to go to about 34 because the whole back half of this, there's like over 10, almost 15 minutes that's just like not relevant. And we'll get there when we get there, but just to kind of give everybody a preview. So we're going to go for about 2 minutes here. Here we go.
Demand ancestry. Here's a few other points. Dan assumes that there are no repeat mutations. He assumes there are no parallel mutations. He assumes there's highly probable mutations arising in different kinds, right? See, I would argue that Dan underappreciates how functional the genome is, which means he underappreciates just how many repeat mutations, parallel mutations, and highly probable mutations there are. Okay. And I got some really excellent feedback from Dr. Rob Carter on some of these points as well. And he provided some feedback through Facebook. So I don't think he minds me giving him a shout out there. And so if the genome is more functional, that means there would be more hotspots. And so Dan wants to assert that mutations are largely probabilistic. But I would argue that mutations might just be more deterministic. And what I mean by that is if God created hierarchically, if the majority of the genome is functional, okay, if design diversity is true, we also know that environment dictates phenotype in many ways. Environment can dictate change in the genome. We know there's strong evidence for non-random change, okay, adaptive change. And so that would apply to different unrelated creatures existing in similar environments. Okay, so if that's the case, then that could explain exactly what we see in terms of the patterns between kinds. Again.
Okay. That was something, wasn't it? That was something. I respond viscerally to to that part, just like, oh, don't say it. Don't. Oh, you said it. That's not good. Okay. So first part here is he says that I assume there's no repeat or parallel mutations. He's talking about convergence and mutational hotspots, regions that are more likely than others to change, and saying, well, that would result in the pattern in different lineages experiencing the same mutations. He has that completely backwards. Anyone who's been, done phylogenetics, is familiar with phylogenetics, knows that convergence is a problem when you do phylogenetics. It misleads you in terms of making your phylogenetic connections, because it makes you think that two things that are actually different are more closely related than they are in actuality, right? So that's just a kind of a fundamental misunderstanding of the methods and the techniques of phylogenetics and how different changes in sequences affect your phylogenetic analysis, right? Like convergence is not going to facilitate your nested hierarchies, right? It's gonna perturb that pattern. It's gonna make it harder to figure out. All right. But then the other thing about this with hotspots and everything, he's kind of beating around the bush here. He's not quite saying explicitly what's going on here. But this whole discussion is really framed around functionality, and it's unstated, but it necessarily also involves purifying selection, right? The idea is that, okay, we have mutations occurring, but you only see the ones that make it through the filter of selection because those are the ones that don't matter. The ones that matter due to functional constraint, those get selected out. I want to again emphasize that this is irrelevant to my argument, because my argument only deals with sequences that we have already determined are not subject to purifying selection. So that just doesn't matter, right? If you see the same mutations over and over because they're the ones that are tolerable, whereas other mutations in the same region are weeded out due to purifying selection, you may be responding to some argument that some biologist made somewhere, but you're not responding to my argument that I made in that debate that he is theoretically responding to. And then he changes gears, and that's where I it viscerally respond to that part where he says that mutations might be deterministic. So we preserve the pattern of the hierarchy that is created, right? We preserve that pattern because the mutations are deterministic. So even as mutations occur and accumulate within specific lineages, you have specific mutations that are always going to occur. So it preserves that structure. I don't know what to make of that. I just don't know what to make of that, because the polite way to say it is that this is an unserious argument, okay? We have direct experimental observation going back, I'm not joking, to the 1940s, where we've very clearly established that mutations are probabilistic. Sure, we have hot spots and we have cold spots, and we have organisms that are actually able to modulate their mutation rate. Mutation rate is actually a phenotype, and you can have faster, slower mutation rates. Absolutely. You can even do that regionally within the genome, and you can say this region of the genome is going to mutate faster than that region. These are all things that can happen. But what we don't have is either just stochastically, we just have mutations occurring, but it's this specific one, then that specific one, then this other specific one, right? We don't have deterministic mutations. And we also don't have organisms able to say, I want this specific mutation and then that specific mutation. Yes, he is walking right up to the line of talking about continuous environmental tracking. Yes, that is exactly what's going on here. It's walking right up to, he's not saying it, but he's walking right up to that line. And again, this is not a serious position to take. This flies in the face of decades and decades and decades of direct observation. So no, mutations are not deterministic. They're probabilistic. You can't use deterministic mutations to explain the maintenance of this theoretically created pattern of nested hierarchies over, thousands of years. You can't invoke deterministic mutations for that. That flies in the face of what we can directly observe in living organisms. That's all I got to say about that. Let's move on. We're going to jump ahead here again because there's a repetitive segment. We don't need to do it. So it's already 50 minutes. We don't need to do it. So we're going to jump ahead to, let's see, we're going to go to 23:22 here. That'll do. And we're going to do this little short bit and then we'll talk again.
A way to differentiate, because I like to talk about frequently how there's a lot of overlap in the creation versus evolution debate. There's a lot of lines of evidence that people put forth to argue for their position that are agnostic to the debate. They're non-discriminatory. They're not really working to advance the ancestry debate because both models can explain the data. For example, homology. Evolutionists would simply argue that you have homologous patterns due to descent with modification. We would argue for homologous patterns due to common design.
Okay. This is like one of Donnie's favorite things to go to. Oh, we have to look at evidence that is discriminatory, and nested hierarchies are non-discriminatory evidence. You can explain them in the context of evolution. You can explain them in the context of creation. Now, first of all, we've just taken this out of the context of the specific thing we're supposed to be talking about. My specific version of this argument, take it out of that context, he's still wrong. Okay, because there's a difference in terms of the level of support an observation provides to a hypothesis, right? Does that hypothesis specifically predict the observation, or is that hypothesis able to accommodate the prediction? For evolution, we specifically predict the observation that we see. For creation, yeah, he can accommodate it. But no, you do the math, it's not a specific prediction. He could accommodate it by saying, oh, there's divine intervention and blah, blah, blah. Like, you can make it work, but it's not a specific prediction, right? So that's the first thing here. The second thing I want to point out is that my formulation specifically of this argument, when we're looking at unconstrained sequences in particular, that is specifically designed to be discriminatory, right? When you're looking at unconstrained sequences, the two hypotheses make opposite predictions. The specific thing that Donnie says he's responding to is like designed to be a discriminatory or designed to be discriminatory evidence, right? So this whole thing is irrelevant to the actual argument he is in theory talking about here. And I can name at least one creationist who agrees with me on this, because in our debate, and this was on January 18th with Dr. Jerry Bergman on Standing for Truth's channel, so he witnessed this because he was moderating, Dr. Bergman agreed with my assessment of this. We went through it, and he agreed that evolution predicts this and creation predicts that. Now, to be crystal clear, as a few of you, I love it, a few of you in the chat have pointed this out, but to be crystal clear, right? The same pattern of nested hierarchies in functionally constrained regions is also discriminatory. We expect that in constrained regions, in genes, for example, in the evolution model, and we don't in the creation model. And there's like math and modeling you can do to that effect, right? We can also show that. It's not what I'm talking about. When you make that argument, creationists always fall back on, yeah, but they were created similar, and similar things. Humans and chimps have whatever gene is more similar than they are in mice because humans and chimps are more similar, whatever. You can do the math and show that creationists are still wrong about that, but it's totally irrelevant to the point that I've been making and the point that Donnie says he is responding to. Right. My argument very specifically is, as he would say, discriminatory between the two options. So now we're going to skip. An analogy here based on a Marvel or DC like multiverse kind of hypothetical. We're just going to skip it. So we're going to jump ahead about a minute, and then we'll go for about another minute here. So let's do this. And then we'll talk about that. Let's do it.
To test the models and to discriminate. We're looking for discriminating pieces of evidence would be DNA function. If most of the genome really is non-functional evolutionary leftovers comprising genomic fossils, viral fossils, genetic mistakes, okay, then the evidence might favor, especially in terms of what we're discussing here, a model of common descent. Whereas if the majority of the genome is functional, this would lend credence towards the position that says we have hierarchies due to design rather than descent. It would also account better for what I have here: repeat mutations, parallel mutations, mutations that lean deterministic rather than probabilistic.
Why are we talking about function? Why do we keep talking about function? It doesn't matter. It's not relevant. And he knows this because he said, hey, when Dr. Dan makes this argument, he says that function's not relevant. It's all about constraint. Yeah. So Donnie, why do you keep talking about function? It doesn't matter for the arguments I'm making. It's not relevant. Again, folks, how many times have I said this in this show? It's about constraint, not function. We're not looking specifically at non-functional sequences. We're looking at sequences that lack constraint. Those are two different things. They often overlap, but we don't care about the function side. We just care about the constraint. I don't know why we keep going back to function. I don't have anything else to say about that. It's irrelevant to the argument I'm making. So now we're going to jump ahead a bit. We're going to skip this long analogy about cars accumulating damage in similar places. That's only actually valid if you have purifying selection leading to the tolerable mutations being the same and you weed out the bad ones, right? That we've talked about this before. Or if mutations are deterministic, neither of those things apply to what we're talking about here because mutations are probabilistic and we're dealing with a lack of purifying selection. So I do just like that he's talking about like cars, and especially in the used market, cars are more likely to be damaged and blah, 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 blah. And as a former used car salesman, I think it's nice that Donnie is leaning on his expertise there. So I do like that. He also gets into the amazing nested hierarchy of vehicles thing. And we're not going to show the clip. It doesn't matter. We're not going to talk about it. But I just love the fact that we're still doing the nested hierarchy in vehicles thing. And he somehow even manages to get this wrong, as though like vehicles without wheels is like the larger group, and then vehicles with wheels is the subgroup. And it's like, well, no, it'd be vehicles, and then wheels and no wheels would each be nested within that. It's just, we don't need to do this again. Vehicles don't reproduce. It doesn't matter. So we don't need to worry about that. So we're going to jump ahead all the way to almost 32 minutes here, almost the 32-minute mark. Here we are. And now we're going to pick this up for about 2 minutes. And then that's where we're going to stop. We're not going to go further in this because I'll tell you what's after that, but it's not relevant to the nested hierarchy thing. So let's wrap this up.
I do want to touch on has to do with the reality that this challenge is actually more of a challenge to Dan. And so I am going to throw this challenge right back on Dan. And I am going to challenge him. We've engaged this in the past, and I believe his answers are insufficient. If we've been evolving for millions and millions of years, okay, accumulating mutations apparently in neutral regions of the genome for millions and millions of years, why are there hierarchical signatures at all in the evolutionary model? Because again, if these mutations are accruing neutrally over millions of years, they should scramble any genetic level homology, any genetic level hierarchy, if deep time evolution was true. Were nested hierarchical patterns and homologous patterns predicted in the genomes of living organisms before their discovery? That's a genuine question. I'd like an answer to that. Okay. Also, the sequences should be changing to the point where these molecular hierarchies are modeled in the evolutionary model, because we understand, and this is a point of contention, but we do understand that the per generation rate does in many ways approximate the long-term accumulation rate or fixation rate. Okay. Fatuma here says what? Since on average it will take 4 NE generations for such mutations to reach fixation, about the same number of neutral mutations should be fixed every generation. The rate of fixation mutations is theoretically constant and equals, notice this, equals the neutral mutation rate. Okay. So why are they?
Okay. We're going to pause it there. We're going to pause it right there, because that's the last part that's actually relevant to the question at hand, right? My argument about nested hierarchies and unconstrained sequences. Okay, so the question that Donnie poses here is, why do the hierarchical signatures exist after millions and millions and millions of years of evolution? Which, hey, look, fair question. Totally fair question. We have a good answer. The answer is that we have the observed mutation accumulation rates, right? We can look at the rate of substitution, the rate at which new variation accumulates in populations, and we can predict the degree of divergence between different groups based on what we think is their time to most recent common ancestor. So we have the observed rates, we can hypothesize when their common ancestor existed, and then we can predict what level of divergence we expect based on that hypothesized time to most recent common ancestor. And wouldn't you know it, the predictions are accurate. So he's asserting that after millions and millions and millions of years, the accumulation of mutations in these regions would disrupt the hierarchical pattern. That's just empirically wrong. Like, we can still show that. The other answer to this, and I love, folks, I love my live audience here, because you all know like what the answers are here. So Nestlig nailed this. This is where the fact that even constrained sequences will show the nested pattern. Yes, this is where you get into the concept that different regions of the genome will accumulate divergence at different rates. So there are certain regions that you need to compare across fairly similar species in order to get a coherent phylogenetic tree, and other regions that accumulate divergence so slowly that if you were to compare, for example, humans, chimps, gorillas, there's too little variation to actually generate an informative hierarchy. But if you compare, but you can use those more stable regions that are highly constrained and accumulate variation slower. You compare those across much broader groups. For example, you can compare the ribosomal DNA, the DNA that codes for the ribosomal RNA. You can compare that, like make a useful nested hierarchy across eukaryotes and prokaryotes. for those regions because it evolves so slowly, because it's so tightly constrained, right? So this actually is where the argument that I've been saying we're not going to worry about, but you can do the same thing with constrained regions, that's actually part of this. But he's just wrong on the assertion that you can't do this across, say, millions of years with the unconstrained regions. You just empirically can. And we verified that by looking at the observed rates of mutation accumulation and then basing predictions on those and showing that those predictions are correct, right? So just Donnie is wrong about the math is the short answer here. All right, and we are not going to show the rest of this video. So we're at 34 minutes in, and it goes until 48 minutes or so. We're not going to show the rest. We don't have to, because this is where he started to go down that kind of mitochondrial rabbit hole, looking at mutation rates and substitution rates, and whether it's the neutral mutation rate or there's purifying selection. So he gets off topic, and he stays off topic for the rest of the stream, talking about purifying selection of mitochondria and stuff like that. That's just not relevant to the topic that we were talking about. Now, I invite everybody to go and watch that, catch the last 12 or whatever minutes of it. Make sure that I'm not, pulling your leg. Make sure that he actually didn't talk about anything relevant to the topic that we've been covering here. I promise you he hasn't, but by all means, everyone should double check me. Don't take my word for it. Go check it out. But I do want to, there is one little moment in there that I want to just thank Donnie for, because at some point in that part, he does point out that the mitochondrial genome is constrained. It experiences purifying selection, and that's great. I appreciate Donnie acknowledging that, because that means the young Earth calculations, like those done by Dr. Nathaniel Jeanson for the time to the mitochondrial most recent common ancestor, right? The time to mitochondrial Eve, those creationist calculations only work in the absence of purifying selection. So thank you, Donnie, for acknowledging the thing that makes the young Earth calculations for the time to mitochondrial Eve wrong. I appreciate that. So let's wrap this up. We can take this down because we're done with the video. So I just want to kind of summarize what we've talked about here. Okay, we looked through this video of standing for truth, Donnie responding to my argument that the nested hierarchical pattern of similarity across what you would call created kinds, specifically in unconstrained sequences that don't experience purifying selection, he was responding to my argument that that observation is one of the single strongest pieces of evidence for the universal common ancestry of all cellular life. Now, as far as I can tell, there are 4 arguments that Donnie made kind of in response to my claim. One that he made multiple times in the video we watched was that those sequences might be functional. Okay, sure, but that doesn't matter. What matters is whether they are constrained or not, right? Whether they are experiencing purifying selection. So that just, I don't care if they're functional or not. Doesn't matter if they're unconstrained. The second one is that they were created with a nested hierarchical pattern, and then they still show that nested hierarchical pattern. That doesn't work because people have actually done the math on that. And I've referenced the papers. And again, the links to those papers are down below. Creationists have not produced any calculations to the contrary, right? We've got peer-reviewed papers showing that the created separately and then maintain that pattern, that's wrong. And creationists haven't rebutted those in any way, never mind writing a paper, getting it, peer-reviewed and published, right, to actually show that their version of events is correct with regard to the starting point being a nested hierarchical pattern. The third argument was that mutations are deterministic. I don't know why you would do that to yourself, Donnie. Why would you even say that? Because mutations are not deterministic, right? That if the mutations are deterministic, we expect a hierarchical pattern because you experience the same mutations in different lineages. Mutations are probabilistic. This is not up for debate. You can go all the way back to the famous luria-delbruck fluctuation test, which I think was from 1942, I want to say was the year. I might have that off by a year or two. But you can go back to the 1940s. We know that mutations are probabilistic. This is extremely not up for debate. And then the final point here was that millions of years of evolution would have obscured the nested hierarchical pattern. And that's not true, because we can directly measure the rate of mutation accumulation, right? We can measure the substitution rate and predict levels of divergence based on that observed rate. And the predictions match what we observed based on the hypothesis of universal common ancestry and those specific common ancestors for different lineages existing at specific points in time in the past. So that that point doesn't work either. So that is where we are going to leave it tonight, folks. As I'm wrapping this up, I see there's about 80 people watching. Thank you all for being here. It is a pleasure to spend this time with you. I love all of you hanging out in the chat right here. You're just, a lot of you are like basically pointing out things that are in my notes that I'm going to be pointing out. So I love that people are following along and kind of know what the beats are going to be. That makes me really happy. So keep that up, folks. Thank you all for being here. Before you leave, please remember to just hit the like button, leave a comment, say something, share this video, send it to Donnie, see if he wants to, take another crack at this one. Give it a try, Donnie. Keep trying. Just keep trying. Go for it. If for whatever reason you're here and you're not already subscribed, by all means, please subscribe to the channel for all your counter-creationist needs. Not all of them. It's mostly genetic stuff. There's other people that do other stuff better. But for your genetics-related counter-creationist needs, I can meet most of those needs here. So thanks, everybody. Have a great rest of your night. I hope everybody is staying healthy and everyone's hanging in there with, the current nonsense that's going on. This is, for watching this in the future, it's March 15th of 2025, so you all know what I'm talking about. All right, have a great night, everybody. I will see you next time.